Hey, welcome back. So in our last explainer, we dove deep into simple sugars, the body's go-to for a really quick burst of energy. Well, today we're going to get to know their more complicated and honestly, way more interesting relatives, the complex carbohydrates.
Right, so we know that candy bar will give you that fast jolt. But what about the stuff that actually powers you through a long afternoon? What keeps you feeling full and really supports your digestive health? Well, the answer to all of that lies with complex carbs, and that's exactly what we're going to unpack right now.
So here's our game plan. First, we'll figure out what complex even means. Then, we'll meet the main players in the complex carb family. After that, we're going to follow them on a little journey through our digestive system, splitting them up into the ones we actually use for energy and the ones that have a totally different job. And finally, we'll connect all this science back to the food you put on your plate.
Okay, let's jump right in. When you hear a nutritionist or a textbook say a carbohydrate is complex, what are we actually talking about here? It really all comes down to their structure. And here it is, the key difference. Remember how simple sugars were just one or maybe two little sugar units? Well, complex carbs are what we call polymers. They're these long, sometimes massive chains of three or more sugar units all linked together. And it's that length, that complexity, that completely changes the game for how our body handles them.
All right, so now that we know what they are, let's meet the cast of characters. Because complex carbs isn't just one thing. It's a whole group of different molecules, and they all have very different roles to play in our bodies.
We can pretty much split them into two main families, and it's all about size. First up, you've got the oligosaccharides. Think of these as the shorter chains, maybe 3 to 10 sugar units long. And then, you've got the polysaccharides. These are the real giants of the carb world. We're talking hundreds, sometimes thousands of units long. Let's start with the smaller ones first.
So what's so interesting about oligosaccharides? Well, here's the thing. Our own digestive enzymes can't touch them. They can't break them down. So these carbs travel all the way to our large intestine, where they become a feast for our good gut bacteria. They're what we call prebiotics, food for our microbiome. Now, the only tiny downside, all that feasting and fermenting by the bacteria is exactly why foods like beans, onions, and cabbage can sometimes cause, a little gas.
Okay, time to move on to the heavyweights, the polysaccharides. These are the massive ones, and they include the three big names you've definitely heard of: starch, glycogen, and fiber. And this right here is where the story gets really cool, because our body treats each of these three in a completely different way.
So let's first follow the path of the polysaccharides that our body can actually digest and use for energy. We're talking about starch and glycogen. These are our main ways of getting and storing glucose for later.
Now, starch, which is just how plants store their sugar, comes in two main flavors, and this is a perfect example of how structure determines function. You have amylase, which is this long, straight, unbranched chain. Because it's so straight, our enzymes can only really work on the ends, snipping off glucose one by one. It's a slow, steady release of energy. But then you have amylopectin. It is super branched, which gives our enzymes a ton of places to attack all at once, and that means it gets broken down really, really fast.
So our bodies have their own version of starch, our own personal energy reserve, and we call it glycogen. We keep it tucked away in our liver and our muscles. The liver glycogen helps keep our blood sugar stable for our whole body, but the muscle glycogen, that's a private fuel tank just for that muscle. And check out its structure. It's even more branched than amylopectin. It's an absolutely brilliant design that lets us release a huge amount of glucose almost instantly whenever our muscles scream for a burst of energy.
Okay, so we've talked about the carbs we can digest for fuel. But what about the ones we can't? This brings us to the fascinating story of fiber, a polysaccharide that takes a very, very different journey through our system.
And this is the central mystery, isn't it? If starch and fiber are both just long chains of the exact same molecule, glucose, why is one of them our primary energy source while the other one passes right through us? What makes them so different?
Well, the answer is surprisingly simple, and it all comes down to the bonds holding those glucose units together. Our digestive enzymes are perfectly shaped to break the alpha bonds that you find in starch. But fiber, its glucose units are linked up by beta bonds. You can think of it like a lock and a key. Our enzyme keys just don't fit into the beta bond locks, so fiber just keeps on moving, totally undigested.
So we can't digest it. But that does not mean it's useless. Actually, it's far from it. As fiber continues its journey, it kind of reaches a fork in the road, splitting into two different types that play two very distinct and incredibly important roles in our health.
Let's look at them side by side. The biggest difference is how they deal with water. Soluble fiber, just like the name says, dissolves in water and forms this thick gel-like substance. And that gel really slows things down in your digestive tract. Insoluble fiber does the exact opposite. It doesn't dissolve at all. Instead, it adds bulk, which helps speed things up. And as you're about to see, these totally different properties lead to completely different health benefits.
So let's start with soluble fiber, the kind you find in oats, apples, and beans. That gel it forms is like a superhero. It actually grabs onto bile acids, which are made from cholesterol. When that happens, your body has to pull more cholesterol out of your blood to make new bile. It's a fantastic, natural way to help manage your cholesterol levels. Plus, that same gel slows down how quickly sugar gets absorbed, which helps prevent those big, nasty blood sugar spikes.
And now for insoluble fiber. Think whole wheat, nuts, and the skin on your vegetables. This is the bulking agent. Since it doesn't dissolve, it just adds weight and softness to your stool, which helps everything pass through more easily and prevents constipation. It's kind of like the broom for your digestive system. It just sweeps things along and keeps you regular.
So, we've covered a lot of the science here. We've got our fast-digesting starches, our slow-digesting starches, and these two amazing types of indigestible fiber. So let's wrap this up by thinking about how all of this applies to the actual food choices we make every single day.
This right here shows you everything you need to know about whole grains versus refined grains. A whole grain has all three of its parts. The outer layer is the bran, which is where the fiber is. You've got the nutrient-packed germ, and then the big starchy part in the middle, the endosperm. Well, the refining process strips away the bran and the germ, leaving nothing behind but that starchy endosperm.
And here's the big takeaway. When you get rid of that fiber-rich bran, you're removing the very thing that naturally slows down digestion. You're basically left with pure, fast-digesting starch, mostly that amylopectin we talked about. And that is exactly why refined grains, like white bread or white rice, can cause those really rapid spikes in your blood glucose.
And that really brings us to our final thought for today. Now that you can picture these different journeys, from the super-fast energy of a refined starch to the slow, steady fuel from a whole grain, and all that crucial work that soluble and insoluble fiber do, how does that change the way you think about balancing the foods on your plate? It's a really important question to keep in mind, and it sets us up perfectly for our next explainer, where we'll look at carbohydrate consumption patterns right here in the United States. Thanks for tuning in.